Hello, my name is William Hobart. I am a fourth year chemical engineering student, and for the past three co-op rotations, I worked at a small chemical plant in Cincinnati called Shepherd Chemical, where the majority of our products were metal complexes that were used as catalysts, and the majority of those products were in powder form, so we had to deal with a lot of solids handling. On my first term, I worked in the organics department, and a few of my bigger projects included creating and updating standard operating procedures to define certain different procedures that we needed to make clear with new equipment upgradings or just processes that had been ill-defined in the past. I had to work with the operators and work with management to solidify a set of steps to reach the end goal. And I really took pride in doing that, even for small tasks, because those are just as important in the grand scheme of things, if to make sure that those don't go wrong. Two other projects that I worked on were ergonomic improvements on the product line. So there was a section where the operators would fill boxes with these pellets and then have to tape them up and pick them up and put them onto a pallet. One thing that I helped with was to retrofit pneumatic cylinders into the tables that had the conveyor belts, the conveyor cylinders rather, because we had operators that were of different height and they needed to raise them up and raise it down to meet their needs. I also helped to plan on where we were going to and how we were going to install a vacuum box lifter that would take all the weight off of the operators' back when they were lifting up the boxes. Instead, have the vacuum lifter hold that weight, and they would put it on. They would just have to direct it onto the pallet instead of actually lifting it up themselves. So I think both of those really showed me that even in a chemical engineering position, you're not always going to be doing solely chemical engineering tasks. So you need to be prepared to do sort of auxiliary functions and sometimes just installing equipment, which might seem more mechanical engineering, you still need to be able to do as a chemical engineer, because that's still equipment being involved in the chemical production process. Something else that I did during that semester was attend bi-weekly meetings with the whole team of the organics department, which I thought was really important to hear what the R&D chemist was doing, the quality control chemist was doing, hear from management what their goals were, and also hear from the operators what their concerns, their worries, and their knowledge was. I just really valued how everyone was able to bring something to the table and everyone was trying to have all their concerns met, and as well as meet their production goals and their quality goals. For my second term, I worked in the inorganics department, and one of my bigger projects for that was to monitor our three of our spray dryer systems, which take in a slurry feed, spray it out at into a really hot spray chamber, and that'll vaporize all the liquid off, and then you're left with a powder product at the end. We had three of those, and they were our workhorse. Well, we had five. The three that I was looking at were our workhorses for certain products, and we were getting a certain amount of yield on one system and not as much on the other. So I would go around and look at what the differences were in terms of the operating conditions and the physical conditions of the systems. And I was able to find a spot where the pipe constricted too much compared to the other systems, so we were having a large pressure difference across there, which in turn meant that not as much airflow was able to flow through that system compared to the others. Another thing that I did related to that system was my supervisor and I we tested an existing system with the spray dryer under different slurry feed concentrations and flow rates to test how much power we were able to get out of this system before overworking our fan beyond its rated capacity or overworking other pieces of equipment beyond their capacity. And we took that data that we got from that, where we were only operating where we felt safely we could make real quality product, and where we had operated before, and I used that data and made correlations to predict where the power requirements on our different pieces of equipment would be projected to be at further more extreme conditions. And with that, I was able to use my chemical engineering knowledge and background and data manipulation to sort of find the correlation and prove that, hey, for this piece of equipment, if we increase our solids concentration and increase our flow rate, we'll be fine. But for the fan at the end of the system, we need to really look into replacing that or getting its power increased, because the current setup is not going to have enough power to draw all the air we need through the system. So I think that was really interesting to look at the data and look at the chemical engineering behind that, and I really enjoyed that opportunity. During that same semester, I was also put in charge of monitoring the chilled water system because we were losing around 900 gallons of water a month in a closed system, or it was supposed to be a closed system. So my manager just told me, hey, this is yours, track it down, and that was kind of it. So I had to go around, look at where all the water lines were, be really diligent on keeping track of how much water we were losing, and just, it was sort of a lesson in persistence, because you have to spot the one time when all the conditions are right for you to see that leak happen, which could happen at any time during the day, even when you're not there. And during my semester, I was able to cut out almost all of that 900 gallons per month, and we were able to start putting back in the chemical that we needed to keep the water from rusting the pipes through. So we not only saved water costs, but we also saved future material costs in replacing those water lines. And for my third term, I was in the research and development area under two different bosses, one in the organics department, one in the inorganics department. And on the inorganic side, I was able to see us try and implement a new process for producing a product that we already made, just in a more efficient way and a more simple way. And the first time we tried that, it didn't work, and we produced product that was too fluffy and actually overflowed a drum we were trying to fill. And so that was immediately halted, and I think that's sort of shows that yes, sometimes research and development, our ideas make sense on paper, maybe make sense in the small scale, but when we go out to the plant size, it doesn't make sense for whatever reason, and we're not sure why. But then we came back with a new approach and tried to match up our old production method with the new production method in terms of speed of material input into the reactor. And after that, we were able to get out good product. So that was really cool to see sort of the steps in how we were thinking of modifying our initial idea of how we can increase production to actually get to a system that works. The other part of my term that semester was I was put in charge of running a not quite lab scale, not quite pilot plant scale, but somewhere in between, We were using a 10-liter reactor tank that mimicked and was a scaled-down version of a tank and continuous dissolver system that we had in the plant. So I was in charge of starting it up in the morning, running it, replacing, it actually used bismuth needles, and having it recirculate and heat up to the right temperature. And we were testing different conditions for what would be the most efficient way to react to make the final product, but also what would be contributing factors in creating a darker color. Because for some of the products we were having a darker color than we expected, and we wanted to know why. So I had to define my own procedure based off of what the lab setup looked like and what the procedure was in the plant. That was also flexible enough to account for all the 10 different process conditions we were attempting to vary. So unfortunately, I was only able to get two of these trials done. So I didn't see the full results because they took days to complete. However, I really enjoyed the startup process because when I got to my semester, my boss just had the setup. He hadn't actually run anything through it. He wasn't sure exactly how it was supposed to operate, so it was a learning process for both of us. We were plugging leaks, we were making modifications, and actually while my boss was away at paternity leave, I was able to order a new part and fit a different section of that system in, so it was easier to take apart and replace those bismuth needles without having to unscrew things. You were just able to pop it out after you take away a clamp. So I really enjoyed that sort of process, even if it didn't produce, I wasn't there producing the results. I was able to sort of define the method that would be used later by someone else to produce the results and sort of find the leaks, find the problems beforehand, and hopefully set someone else up for success. I really enjoyed that too. So overall, had a great 3 semesters at Shepherd Chemical so far, and had a wide variety of experiences where I think I sort of expanded my horizons beyond just thinking about chemical engineering problems like thermodynamics and transport, and sort of was able to see what it takes to actually run a chemical plant. So thank you.